To solve a very interesting lead code problem, that is grumpy bookstore owner. Here in this problem, we have been given a customer array denoting the arrival time of the customers at the bookstore, and also another array which denotes the state of the book owner at a particular instant of time, and another variable called minute which denotes the maximum consecutive times that book owner can be happy at a time. We will understand this by using some test cases. Let's say in the first test case, we have been given an array of customers. In the 0th minute, one customer arrived at the store and they left at the store after the 0th minute. In the first minute, no customers arrived. In the second minute, one customer arrived, and at the end of the second minute, one customer left. In the third minute, two customers arrived, and at the end of third minute, they both of them left. So this is the customers array. And now there is another array called grumpy. Here the 0 denotes the book owner is happy and he served the customer with satisfaction, and the 1 denotes the book owner was angry and he was unable to serve the customer. So let's understand this. In the 0th minute, the book owner was happy and he served this one customer with happily. So this customer is satisfied. In the first minute, the book owner is grumpy, but fortunately there were no customers that arrived in the store, so no problem. In the second minute, book owner was happy also. He served the customer with satisfaction. In the third minute, he was grumpy, and unfortunately there were two customers at the market, and the both the two customers were unsatisfied. So the to satisfy maximum number of customers, book owner has a secret trick upon its sleeve. That is, he can have a consecutive of these 3 minutes. He can be consecutively 3 minutes happy and can start the customer with satisfaction. So we want to figure out how many maximum number of customers he can serve with satisfaction. The trick, for example, let's say the book owner is happy for these 3 minutes, that is 5, 6, 7. For these 3 minutes the book owner is happy, so he will be able to serve 175, this, that is 5 plus 7, 12, 12 plus 1, 13 customers with happily. Now in front of this array, the book owner happy was this one, that is 111, that is 13 plus 1, that is 16. So if book owner remains calm, remains happy for these 5, 6, 7 minutes, you will be able to serve 16 customers with satisfaction. So this is the problem. So now one thing, it can come to our mind that suppose you have been given a, a size, or let's say you have been given a time constant or anything, something consecutive you can apply on the sub array. Normally some those who are practiced, those who are experienced, naturally sliding window problem comes to my mind, right? So naturally what we can do is that we can find the maximum sub array of length 3 that has a maximum sum, right? So this is the maximum one. So what we can do, we can find the maximum of this 3 array, that is 13. Now we can find out the length of this, we can find out the sum of this sub array window of size 3, that is 13, and add up with the rest of the 3 and it will get 16, right? This sounds very easy, right? But it is ain't that easy problem, right? It is a little bit tricky problem. So while for this we have a second test case. Let's say we applied a slide window of size 2. We computed the maximum window of size 2, so it will be 10 plus 10, 20, right? So what we'll do, we will make the book owner happy for these two consecutive minutes, and he will serve these 10, 10, 20 customers, and this will be the answer, right? And because the book on, I cannot satisfy this one because I have satisfied the already two customers, this will be left out, so I cannot have this one in my under satisfaction limit. So 20 will be my answer, but the problem is that for this the correct answer is 24, because if I satisfy, because the this at this point of time the book owner is already happy, so uh, don't need to forcefully make this book owner as happy, right? So we don't need to apply the if sliding window effect for this sub array, right? So what we do, if we make these two, if we make the book owner happy for this two instant of time, so what we'll do, 4 plus 10, that is 14, 14 plus 10, 24, 24 will be the correct answer. So what we can do, we can do one thing, we can have a, just like any other sliding window, we can have a sliding window of size 3 and just try to know how many unsatisfied customers we have within this size. For example, in the earlier test case, in this, let's say in the first sub array of size 3, the owner was grumpy for this instant, and there was zero customers that were unhappy, right? In the second instant of time, that is this one, the book owner was grumpy for this one and this one, and the number of customers that were unsatisfied was 2, so it was 2. So likewise, we can find out the maximum number of unsatisfied customers that can be possible for a particular sliding window size 3. For example, if you look carefully for this sliding window size 3, the book owner was unhappy for this fifth index, fifth minute and seventh minute. So the total number of customers that were unhappy was 1 plus 5, that is 6. 6 was the maximum number of customers that were unhappy for the sliding, if we take the sliding window size 3. So if we so we know to have a maximum customer, to give maximum customer satisfaction, we need to apply the effect on this sub array. So all of these will come under my satisfied customers, and just scan through the rest of the array, and for those which when the book owner is happy, just add to the count. So it will be the solution. So it was a bit tricky problem. Obviously, it was not that easy sliding window, because I was initially thought of making, finding the maximum subarray of size 3 and find it out and add up to the another thing, but it is not a good solution, right? Because this test case will fail, because here you need to apply the effect on this two part, in this part, right? Because this portion is already happy, this custom this because at this point of time the owner is already happy, so you don't need to satisfy make satisfy this customer. This customer will all be happy. So let's understand through the code. Mhm. Let's take out the length. Let's take out the length of the array. Now let's say unsatisfied customer. Now we need to build the sub array slide window of size minutes. So I will loop from I equals to 0, I less than minutes. I need to first build the sliding window. That is, now if the book owner is grumpy, if the book owner is grumpy, obviously the customer will be unsatisfied, na? So let's add to the unsatisfied customer tally. Unsatisfied customer tally. Okay. So let's say in the for the first sub array of size 3, only this time the book owner was unhappy, right? But there were zero customers, so no customer in this portion, no customer was unsatisfied, so it will be 0. And for this array, the sliding window was of size 2, and the number of and in the both of this time instant, the book owner was unhappy, and the total number of unsatisfied customers will be 14, so the result will be 14. So now I have the maximum, I need to find the maximum unsatisfied customer. Let's say let's say this is the unsatisfied customer. I have stored it in max. Let's say, let's for sliding window we need to have some LNH to denote the boundaries of the window. Obviously the H will be denoting high, that is this minute. It will be the end of the window, and I need to count the time, start time and end time. There will be something like start time and end time, right? Because for this window I need to note the, for let's say for this window we needed to note the time at which the window will start and the time at the window which will end. Because for them i will just I will just count all the customers, because they will be always satisfied, because I will forcefully make them happy, forcefully make the owner happy. So what to do? Let's rotate the slide the window, that is while age less than n. Now for this it is just like another sliding window. Now let's say if I'm leaving this, if let's say for this it was first sliding window was like this. Now the sliding window will be like this, so I will leave out the first one. So let's say if the owner was grumpy at L, so I will deduct this na. It is those who have coded earlier sliding window will know this what I am doing. So I need to deduct it, and just like low I need to make sure for high, if something is coming, if something is coming and that is grumpy, that is one, I need to add this to my count, right? Now let's say we found a new maximum, that is if unsatisfied customer is greater than the max unsatisfied customer, that is I need to update it, correct? And also I need to at the start time and also the end time, because I need to know the when the slide, when my result starts and when the result ends. Now I need to just keep moving the thing, so I have it. So I, after this I have the time instant for the maximum survey of size k, that has a maximum unsatisfied customers. Now I have all the unsatisfied start time and end time for the max unsatisfied customers. So I, what we can do, I will intentionally make them all happy. Let's say if I is greater than start time and I is less than end time, I will make them happy. This is very, this is very ordinary. Now unless it is, I need to just make sure if my manager or if the book owner is grumpy, that is one, that is no, book owner is cheerful, that is zero. So all those customers that came to my store when the owner was happy will be all satisfied na. So add them. So so this result is my answer. I did make some problem, of course, just like every time. Yeah, the test case passed, because the normal instinct of anyone who has coded sliding window before will be to calculate the maximum window of customers, and we will relax all them, we will make them all them happy and we'll count afterwards. But this is a very wrong approach. This test case will pass, but this type of test case won't pass. This was the mistake I did when I approached the problem. So the time complexity of this problem will be order of n, obviously. and the space complexity will be order of 1. We haven't added any kind of extra space, so it was the solution for them, and it was an easy solution. Please go through the problem again and you will understand why this coded up. And that's it from me. Thank you.